Good afternoon, friends. I, Dr. Devesh Pandil, Associate Professor, Suresh Gyan Vihar University, accredited by NAC A grade. Today, I will discuss about network model. You know, network model is the one of the model of your database model. You know, database database where you will store the information. Your database is the consist from your two word database management, that is your dbms. So database where you will store the data, and management store the data and manage the data. This is your dbms. And now here I will discuss about the network model. I am sharing my screen. I hope you can see my screen. you know your database models are hierarchical model, network model, entity relationship model, and your relationship model. And the network model is one of the model of database model. During this lecture I will discuss about so many topics like your object and outcome of network model, and also I will give the overview of your database model. Also I will give the hierarchical model, network model I will explain in your detail, and your entity relationship model, hierarchical model, and your relationship model I will discuss. Only I will give only overview, and er model and your relational model. Okay, first I will discuss about object and outcome of your network model. you know Network model is one of the model of your database model, and database model is the important part of your dbms. As per I had told, your dbms is the consist from two words: database management, database where you will store the data, and your management, you will manage the data. you know your software, if we will talk about the software is consist from the two parts. First part is your front end, and second part is your back end. In your front end you will take the many programming language like your c++, java, asp, php, c sharp. And if we will talk about the back end, in your back end you will take the database. Okay, database is the must compulsory. Without your database any software will not complete. Like, suppose you want to take a yeah you want to make a software of your college management system. If you want to make a software of our college management system, so you will take front end. In your front end you can take the any programming language, and also you will take the database, because all college information will store in your database, like your student information, like your teacher information, like your courses information, like your fees information, like your program information, etc. Okay, and if you are not having a database, so how to access the data, how to store the data? That's why your database is the compulsory. If you are having a database in your software, so you can store the data in your bulky manner, and you can access the data from the database. Like, suppose you have to store the 1 lakh student data in your database, and you want to access the data of your particular student. So that is possible when, if you are having the database. If you are not having the database, so how is possible? That's why your database DBMS is the must compulsory. Okay, and the object of this lecture is to understand the concept of your network model, and we will talk about the outcome of this lecture is to how to draw the network model. Student will able to how to draw the network model. Before discussion about network model, I would like to discuss about the database model. Database model define the logical design and structure of a database, and define how data will stored, how data will access, how data will update. So through the database model, either your hierarchical model, either your network model, either your entity relationship model, either your relationship model. So through the database model, you can define the structure of your database. You can also define the logical design of your database, and also you will define how you will store the data, how you will access the data, how you will update the data. So that's why your database model is compulsory. You know, four models are hierarchical, network, relationship, and your ER model. Relationship model is most widely used in your database model. Why? Because the relationship model where you will store the data in your tabular format, where you will store the data in your two dimensional. Your one dimensional is for row and second dimension is for column. Like if you are using a database, suppose you are using a database of your student, and your student database management system, there are so many tables. Here I am discussing about only one table of your student, like your, and you want to store the data of your student. Okay, in your student table, your student attributes are student name, father name, mother name, address, student ID, etc. And here you are storing the data of your student. So when you will store the data of a student, so your data will store in your tabular format, in your row and column format. Okay, that's why I had told relation model is most widely used in your database model. And there are four types of database models. First is your hierarchical model, network model, ER model, and your relational model. I had also talked about the hierarchical model and ER model and relational model in my previous lectures. Here, I will discuss in briefly about the network model, and also I will give the overview of your hierarchical model, ER model, and your relationship model. First of all, I am giving the overview of your hierarchical model. If we will talk about the hierarchical model, you know, in your hierarchical model, your data will store into your tree structure format with a single root. In this model, if you want to store the data, so your data will store in your tree structure format with a single root. Means in your hierarchical model, your single root will exist, and the other data is linked from the single root. Okay, and your hierarchy will start from your upper level. Also you can say that your hierarchy will start from the root data, and your other data will store in your other data will be linked from your root form, from your root. So as per I had told, your hierarchy will start from your root, and you will expand like a tree, and you will add the child node to the parent nodes. Okay. And in this model, a child node will only have a single parent node. In your hierarchical model, your parent node have only your child node will only have only one parent node. Okay. And this model efficiently describe many real world relationship like index of a book recipe. And in your hierarchical model, data is organized into a structure format with one to many relationship. You know, there are four types of relationship in your database. First is your one to one, second is your one to many, and the third is your many to one, and fourth is your many to many. Your one to one means the entity of your one table is linked from the one entity of another table. This is your one to one. And if we will talk about the one to many, so if your one entity of a table will linked to many entity of another table, this is your one to many. If we will talk about the many to one, many to one means where your many entity will linked from the one entity of another table. And fourth is that many to many, where your many entity of a one table will link to many entity of another table. So these are the four types of relationship are existing in your database model. And your hierarchical model will support the only one to many relationship. Okay. You can take the example of your one to many relationship like your department. Okay. You know, your department have many courses, your department have many professors, your department have many students. Means here you can establish the one to many relationship. Your department is only one, and there are many courses, there are many professors, there are many students are existing, okay, in your one department. That's why you can establish the relationship between the department and in our department there are so many professors, there are so many students. And in this diagram you can see the example of your hierarchical model. Your college is your single root. Okay. And you know, your department and infrastructure both are child and both are connect from a one parent node, you can see in this given slide. And also here I had already discussed about the your hierarchical model will support the one to many relationship. So you can see in this given slide, your course, teachers, students will connect from the only one department. And as per I had told, there are so many courses are exist in your one department. There are so many teachers and there are so many students. And here you can see your courses, your teachers, your students are connected from your department, and your theory and labs are connected from your course. And here you can see your children have only one parent node. In this example, there is no any children who have more than one parent node. All of children's having only one parent. And after discussed about the network model, here I had also given the overview of a hierarchical model. I am not going to depth of a hierarchical model. And now I will discuss about the network model in depth. Okay. You know, Your network model is the extension of your hierarchical model. You can see that your network model is the extension of your hierarchical model. And in this model, the data is organized more like a graph, and the allowed to have more than one parent node. And whereas if we will talk about the hierarchical model, so in your hierarchical model, your data will store in your tree format. And in your hierarchical model, only parent or child node have only one parent node. And in your network model, you can say that your network model is the extension of your hierarchical model. And in this model, your data is organized in your like your graph, and the allowed to your child node will have more than one parent node. Okay. And there are two fundamental concept of a network model. First is your record content field, which need hierarchical organization. Okay. And second is that sets are used to define one to many relationship between records that contain one owner, many members. Okay. A record may act as an owner in the number of set and a member in the any number of sets. Okay. So the main key concept of your network model, your data will organize in your network model in a graph format, in a like your graph. And in your network model, more than one parent can exist. Okay. And whereas in your hierarchical model, only child node have only one parent node. And in your network model, your child node have more than one parent node. A set is designed with the help of your circular linked list, where one record type, the owner of the set, also called a parent. You know, circular linked list. Here I am giving the overview of your circular linked list. Circular linked list is the one of the type of your linked list. Your linked list where your all nodes will connected through the each other, where your one node will connect from the another node, and your next node will connect from the another node. And your node will consist from the two parts. First part is your data part, and second part is your pointer field which point to the next pointer. And if we will talk about the circular linked list means where your node are organized in your circular fashion, where your where your first node will connect from your the last node, and your last node will connect from the first node. Okay. Appears on the each circle. And the second type, also known as the subordinate or your child, many appear multiple times in your each circle. And in your network model, a hierarchy is established between any two record types, where one type is the owner of your another type. And at the same time, another set can be developed, where the latter set B is the owner of the former set of your A. In this model, your ownership is defined by the direction. Thus, all the sets comprise a general directed graph. So, the main key focus point in your network model, your more than one parent node can exist. Okay. And here your data will organize in your like your graph. And if we will talk about the features of your network model, there are so many features of your network model has the following features are: it can represent redundancy in data. Redundancy redundancy, like your duplicacy. in your database management system, if we will use the normalization, so you can reduce the duplicacy, you can reduce the redundancy. Okay, normalization is the important topic of your database management system. If you are not using the normalization in your database management system, so your database is nothing, because in your database your one record will exist in your many times, and if your one record will exist many times in your database, so obviously you will face the problem. Why you will face the problem? Suppose you want to update the address of your student. Okay, and your student record and your particular student record are existing the many times. Okay, so here is the, obviously you will face the problem. Okay, that's why your normalization is the most compulsory in your database management system. With the normalization you can remove the redundancy, you can remove the duplicacy, and also you can say that you can through the normalization your duplicacy and your redundancy will reduce. Okay, that's why we will use the normalization. There are so many forms of your normalization, like your 1NF means first normal form, second NF second normal form, third NF third normal form, and your BCNF bio code normal form. Here I am not going in your depth of your normalization. I will discuss about the normalization in my coming upcoming lectures. Here, I had only given the only overview of your normalization. Okay, so it can represent the redundancy in data more efficiently than in the hierarchical model. Okay, in your network model, it can represent the redundancy in data more efficiently than the hierarchical model. There can be more than one path from a previous node to successor node. Means if you will draw the network model, if you are using the network model, so there can be a more than one path from a previous node to the successor node. And the operations of the network model are maintained by indexing structure of your linked list, where a program maintain a current position and navigate from one record to the another by following the relationship in which the record participates. Okay, and record can also be located by supplying key value in your network model. Okay, key value like your primary key, like your candidate key. Primary key, in your primary key you can take the one or more than one attribute as a primary key, and through the primary key you can identify a particular record, you can identify a particular tuple. For example, suppose you are having a table of your student, and there are so many students are already stored in your student table, and the attributes of your student table are student name, student father name, student mother name, student class, student ID, student passport number, student Aadhaar card number, student PAN card number. And from this table, you can identify a particular student, you can identify a particular tuple. Okay, so you can identify a particular tuple through the primary key. Here you can take the only one attribute as a primary key, is that student ID, because your student ID you can identify a particular student, because your student ID is unique, and if your student ID is unique, so every student will have independent unique ID, will have unique ID. That's why you can make the student ID as a primary key. And also I had already told, you can take the one attribute and more than one attribute as a primary key. So in this given example, as per I had told, you can take the student ID, student Aadhaar card number, and student PIN card number. Student Aadhaar card number is unique, student PIN card number is unique, and you can take the more than one attribute like your student ID, student Aadhaar card number, and your student PIN card number. Okay, and through these attributes, you can identify a particular student, because the definition of your primary key, through the primary key, you can identify a particular record. And the following diagram, a network I am giving, I will mention a diagram in my next PPT of a network model, and where your agent represents several clients and manages several trainers, and each client schedule any number of engagements and makes payment to the agent for his and or her service. Each entertainer performs several engagements and may play a variety of musical style. I will show you my diagram. Okay, here you can see the diagram of your network model. Here in this diagram, your agents represent the many clients, and your agents and your manage trainers, and your clients is client connected to the payments schedule, and your entertainers, your perform and your play and payments, engagements, and your music style. So here you can see the diagram of your network model. Here collection of records is represented by a node, and a set structures help to establish a relationship. A network help to this development, help to relate a pair of your nodes together by using one node as an owner and the other node as a member. One to many relationship is managed by a set structures, which means that a record in the owner node can be related one or more records in the member node. Okay. Additionally, a record in the member node cannot exist without being related to an existing record in the owner node. For example, your client must be assigned to an agent, but an agent with no clients can still be listed in your database. Here you can see your agents will connect to your clients, your agents will connect to your owner node, and your set structures, and your clients is your member. Okay, and you can see in the above diagram, so a diagram of your basic set structure. One or more set can be defined between a specific pair of your nodes, and a single node can also be involved in the other set with other nodes in the database. The data can be easily accessed inside a network model with the help of your appropriate set structure. In this network model, if you are using the network model, so through the network model you can access the data in your easy way. There are no restriction on choosing the root node. The data can be accessed by any node and running backward or forward with the help of your related sets. And if we will talk about the advantage of your network model, the main advantage of your network model is your fast data access. If you will use the network model, so through the network model, you can access the data in your fastly mode. Okay, means you can fast data access. And also another advantage of this model is that it also allow user to create queries that are more complex than those they are created using a hierarchical database. So a variety of query can be done over this model. These are the advantage of a network model. Main advantage through the network model. If you will draw the network model, if you are using the network model, so you can access the data in your fastly way. And if we will talk about the disadvantage of your network model, a user must be very familiar with the structure of the database to work through the set structure. Updating inside the database is a tedious task. One cannot change a set structure without affecting the application program that use the structure to navigate through the data. If you change a set structure, you must most widely all the references made from the within the application program to that structure. In this database, data is more related as more relationship are established in the database model. Also, as the data is more related, hence accessing the data is also easier and fast. I had already told about that. If you want to access the data through the hierarchical model and network, so in your network model, you can access the data in your fastly way. The database model was used to many data relationship. In your in your hierarchical model, your relationship is to your one to many. And in your network model, your relationship will exist to many data relationship. You can see here your A will connected from your B1, B2, your C1, C2 connected from your B1, your C2 connected from your B2, and C3 connected from your B2. Here you can see, as per I had told, here is more than one parent is allowed. Here C2 is your child node, and your C2 has the more than one parent node B1 and your B2. And about the ER model, I had already discussed about the ER model in my past lectures, but here I am giving the overview of your ER model. ER model, like your stand entity relationship model, where you will define the relationship between entities. And you know what is entity? Entity is a person, place, or thing. And your entity will have some features. Your entity will have some characteristics. Okay, like your student, student is your entity. Table is your entity. Teacher is your entity. And your characteristics of your student, characteristics of your teacher, characteristics of your table. If I will take the student as a teacher, student as an entity, the student name, father name, mother name, student ID, student roll number, etc. These are the all characteristics of the of student. If you will take the teacher as an entity, your teacher ID, your teacher name, father name, teacher salary, teacher date of joining, these are the all attributes, all characteristics of your teacher entity. If you will take the table as your entity, so your table diameter, table cost, table height, table width, these are the all characteristics of your table. Okay, you know, characteristics and features of your entity is called the attributes. Okay, your entity classified will within two category. First is your tangible entity, and the second is your intangible entity. Tangible entity are those entity who are exist in your real life, in your physical manner, like your car, your person is your physical tangible entity, because these are all will exist in your real life in your physical manner. And the second is your tangible and intangible entity. Intangible entity is just a reverse of your tangible entity. Intangible entity are those entity who will not exist in your real world in your physical manner, like your bank account. And if we will talk about the types of your entity, so there are so many types of your entity, like your strong entity and your weak entity. Strong entity, strong entity are those entity who have key attribute. Okay, like your student is your entity, and the student date of birth, student ID, student roll number. These are the all attributes of a student. So here your student ID is your key attribute. Student roll number is your key attribute, because behalf of your student ID and your student roll number, you can identify a particular student. So your student will be a strong entity. And if we will talk about the weak entity, so your weak entity just reverse of a strong entity. Your weak entity are those entity who have no any key attribute. It's called the weak entity. And also you can say that if your one entity is depend on your another entity, so it's called the weak entity. Okay. And now I am giving the overview of your attribute. Attribute, as per I had told, all characteristics, all features of your entity is called the attributes. And there are so many types of your attribute, like your simple attribute, multiple attribute, your key attribute, your derived attribute, your single valued attribute, your composite attribute. If we will talk about the simple attribute means if you cannot broken this attribute, it's called the simple attribute. Means your simple attribute are those attribute who cannot broken, who cannot break, like your age. You can't break the age. You can't divide it the age. This is your simple attribute. Okay, composite attribute. If you can divide the attribute in the many sub attributes, like your name, like your address. Name will divide in your first name, middle name, and your last name. Address is divided in your street, pin code, city, area, colony. Okay, and if we will talk about the single value attribute, who at single value attribute, those are attribute who have only single value, like your age, like your date of birth. Both are single attribute. And if we will talk about the multi-valued attribute, multi-valued attribute are those attributes who have more than one value, like your student mail ID, student phone number, because your one student can have more than one phone number. One student can have more than one mobile number. This is your multi-valued attribute. If we will talk about the derived attribute, your derived attribute is not directly present in your is not a physical present in your database. You can derive the attribute from the another attribute. Like if your date of birth is mentioned in your database in your one column, and you want to derive the age is not physically mentioned in your database, so you can derive the age from your date of birth. Okay, this is your derived attribute. And your key attribute from which you can identify a particular record, you can identify a particular tuple is called the key attribute. This is the overview of your ER model. Here you can see this example in your database. I am not giving the detail of ER model because I had already discussed in my previous lectures. And I will give the overview of your relational model. Relational model means where your data will organized in your tabular format, where your data will organize in your row and column format, in your two-dimensional format. Your one dimension is for row and second dimension is for column. For example, you can see in this given slide, your data is organized into your tabular format, two-dimensional format. And here I have taken some questions which are related from this lecture. Which of the following gives a logical structure the database graphically? You know, entity relationship diagram gives a logical structure of database graphically. Okay, and I had already discussed about the entity relationship diagram in this lecture. The entity relationship set is represented in ER diagram. Okay, so your entity relationship set is represent in your ER diagram. Okay, and answer is D. The rectangles divided into two parts represents entity set, relationship set, attribute relationship set, and your primary key. So your answer is your entity set. The rectangles divided into two parts which represent the entity set. Consider a direct line from the relationship set as well to both entity set, instructor and student. The indicate the one to one cardinality. We indicate roles in a ER diagram by labeling the lines that connect to a diamond and your rectangle. You know, when you will represent the entity, so your entity will always represent in your rectangle. And when you will represent the relationship between the entity, so your relationship will represent in your diamond shape. For a weak entity set to a meaningful, it must be associated with another entity set called the identifying set. Weak entity I had already discussed. If your one entity is depend on your another entity, if your entity who have no any key attribute is called the weak entity. An entity set that does not have a sufficient attributes to form a primary key is termed as your weak entity set. About a weak entity set I had already discussed. Weak entity set is represent as a your double diamond, and your strong entity, your strong entity is represent in your single rectangle. Okay, and your here is your answer, your double rectangle, not a diamond. Okay, your answer is D, double rectangle, not a double diamond. Your big entity set, okay, your big entity set, your big entity, if your one entity is depend on your another entity. And if we will talk about the strong entity, so your strong entity are those entity who have key attribute. And if you are collecting and storing information about your music collection, an album would be considered a relation, entity, stance, and your attribute obviously is that entity. After studying this lecture, student will able to about the network model, how to draw the network model, what are the advantage and disadvantage of your network model. I hope you have to understood about the concept of your network model. Thank you.